and this is from the chapter review, and this is number 23. We're going to take a look at letter A. And so it says sine of x equals -1/2, and of course that's in radians, so we want the answer x to be in radians, not degrees. And it says, what is the general solution using the angle measure specified? Okay, so they want the general solution. So I guess first of all we can just take a look at sine of x equals -1/2, and we can try and figure out, okay, where does sine of an angle equal -1/2? So if we think about the unit circle, you can go back to your unit circle. You might remember that the first coordinate is cosine, the second is sine. So we're looking for a second coordinate of -1/2. So if we go over √3/2 and then down 1/2, that's going to be -1/2. So this is the angle, this is one of the angles we're looking for. And let's see, where else is sine -1/2? Well, I guess that would be over here, right? So it could be for this angle in the positive direction and this angle, or this angle in the negative direction and this angle in the negative direction. So let's just take a look at the positive ones first, right? So -1/2 here is this angle right here. So what is that? Well, √3/2 +1/2. What angle does that refer to? So again, you can look on your unit circle, but where we have √3/2 and comma 1/2, what angle is that? That is going to be 30. Is that 30 degrees? Right? Over √3/2 up 1/2, so 30 degrees, or in radians, that's pi/6 radians, right? So you just want to check your unit circle to make sure, and I'll just do that real quick here. So here's a unit circle, so +1/2 pi/6. While we're here, let's take a look at the -1/2. Here's the -1/2, and so I know that this angle is going to be 11 pi/6. Here's the other -1/2, so we're looking at 7, so that's 7 pi/6. So that's in the positive direction, this way and this way. Now the general solution, okay, so when asked for a general solution, you could do couple things. You could do theta equals 7 pi/6 plus, now let me get back here, you could do theta equals, the first one is 7 pi/6 plus or minus 2 k pi, where k is an element of natural numbers. So that means that you can add 2 pi multiples, any multiple of 2 pi that you want, and you get all of the answers. You could also subtract 2 pi, you get the same thing in the negative direction. You could do the same thing for this, 11 pi/6 plus or minus 2k pi, where k is an element of natural numbers, right? If you want to drop the negative, like the textbook does sometimes, then you just have to change this n, natural numbers, you have to change that to integers. Okay? Now, you can't, that's fine for me. If you want to do that, list the angles plus 2k pi, that's fine for me. What you also could do, and this gets a little bit trickier, and I'm not sure if the textbook really encourages this or not, but there is a way where you could actually just name one of these angles, and then you could say, you know what we're going to do, we're going to add pi/2. See, that's pi/2, another 90 degrees there. That's not true. I might have to back up on that. But if it was in multiples of pi/2 or multiples of pi/3 or something like that, then you could add multiples of pi/3. But I would suggest probably just doing it this way. List the two angles that you have, plus or minus 2k pi or whatever like that. Okay, so let's just double check this. Take each angle, plus or minus 2 pi, and you'll get all of the other angles. That's what the general solution means. So you have to kind of add multiples of either. Sometimes it's multiples of pi/2 you can get away with, right? Like every halfway around the circle. So you could say, give your angle, and then if the angles match up. So for example, if the two solutions were here and here, I could just say this angle plus, multiples of pi over 2. And that would hit this one, and then bounce back and forth, right? And go all the way around. But with this case, when these aren't within reasonable multiples, just list both angles and 2 pi k.